Hello, knowledge seekers. In this episode of 20-Minute Books, we delve into the revelatory insights of Why We Eat Too Much by Andrew Jenkinson, a renowned consultant surgeon specializing in advanced laparoscopic surgery. Published in 2021, this compelling read challenges long-standing diets and myths, shining a light on the intricate science of metabolism. Jenkinson, whose expertise is rooted in his practice as a gastrointestinal surgeon at University College Hospital in Bloomsbury, London, takes us on a journey to understand how our bodies convert the food we eat into vital energy for our cells. More than just another diet book, Why We Eat Too Much debunks common misconceptions and offers a profound comprehension of appetite that paves the way towards a healthier relationship with food. This book comes highly recommended for individuals fed up with fruitless dieting, those with a passion for science, and anyone looking to break free from the grip of sugar addiction. Prepare to transform your understanding of eating well as you explore the fascinating connections between body, mind, and nutrition, all within an invigorating 20-minute exploration. Why We Eat Too Much, The New Science of Appetite. Introduction. Unlock the secrets to weight management by understanding metabolism. If the cacophony of dietary advice has left you bewildered, fats are the enemy today, carbs tomorrow, you're not alone. It feels like we're in a continual tug of war with calories, losing weight just to gain it all back, with a little extra to boot. The struggle is real. The frustration, palpable. Could it be that we're missing a piece of the puzzle? Enter the world of metabolism with surgeon and weight loss expert Andrew Jenkinson, who proposes that real, sustainable weight control comes from knowledge, not fads. It's time to cut through the myths and explore how our metabolism truly operates. In this enlightening journey, be prepared to discover the ancient origins of our metabolism tracing back 4 billion years, why a calorie deficit diet might set you up for a weight rebound, and how the demonization of certain fats contributed to the surge in obesity. With each insight, you'll arm yourself with the wisdom needed to make informed choices for lasting health and weight management. Part 1. The Dawn of Energy: How Ancient Organisms Shaped Our Metabolic Destiny. Take a moment to marvel at the Earth's humble beginnings, a vast tapestry of churning seas and murky skies, inhospitable and devoid of oxygen. Amidst this desolate expanse, life was but a dream in the form of inert carbon concoctions until a twist of fate sparked a grand biochemical experiment: replication. These pioneering molecules absorbed the riches of their aqueous cradle, splitting themselves to forge the earliest strands of something akin to DNA, the blueprint of life. Gradually, complexity blossomed, culminating in the emergence of the first living protagonist of our tale, the single-cell bacterium. A pivotal turn in evolution changed everything when single-celled entities encountered an issue. Their energy production was capped due to their inability to utilize oxygen. Nature, however, is the mother of invention, and a new strain of bacteria evolved like microscopic power plants, gorging on nutrients and transforming them into boundless energy. It wasn't efficiency, but sheer output that set them apart. Faced with potential obsolescence, the old bacteria embraced an ingenious solution: ingesting these oxygen-using marvels without digesting them. This mutual arrangement, endosymbiosis, became the foundation of a shared existence where one provided sanctuary and the other the gift of energy. And so, we arrive at our current biological inheritance. Our cells hold mitochondria, the direct descendants of those ancient microbial generators. These tiny organelles continue to fuel every breath, thought, and heartbeat. Without this symbiotic legacy, the elaborate tapestry of life, from the smallest plant to the grandest creature, would simply unravel. Part 2. How Humanity's Evolution Hinged on a Metabolic Trade-off. Imagine the cornucopia of life on Earth as a sprawling family tree, with its roots anchored firmly to a common ancestor, the simple, single-celled progenitor that bequeathed the gift of energy conversion to all. From verdant rainforests to the vastness of savannas, every organism, sedentary or sentient, exercises this ancient birthright within its cellular furnaces, the mitochondria, producing the vital energy molecule ATP. But life's banquet comes with a tab, and each species has a predetermined energy allowance, meticulously allocated to every beat, breath, and bloom. It's a balance sheet of biology, accounting for survival within the limits of available resources. Now, consider humanity's unique conundrum. Our disproportionate brain power comes at a steep metabolic cost. Rewind 250,000 years, and you'll find our ancestors, Homo sapiens, at a biological crossroads, their brains burgeoning compared to their predecessor, Homo erectus. The human brain, that insatiable consumer of calories, demands a fourth of our daily energy intake. Was this cerebral expansion an extravagant gamble? How did prehistoric bean counters justify this metabolic splurge? The answer is nothing short of evolutionary thrift. Nature, it seems, decided to economize on other organs to bankroll our cognitive largesse. Zoom in on the mammalian energy budget, which scales with size like a meticulous ledger. A human and a St. Bernard dog, tipping the scales equally, share a roughly equivalent caloric necessity to sustain their physiological functions. Yet when we peer closely, we find humans have managed a metabolic sleight of hand, outstripped only by our closest genetic cousins, the great apes. These mighty creatures, ambling through their leafy domains, boast organs similar in heft to ours, but with a crucial divergence. Our cerebral cortex is quadruple in size, the secret to our financial wizardry, the ancient art of cooking. While a gorilla invests a significant portion of its energy in managing a lengthy digestive system fit for a herbivorous diet, humans have bypassed this energy drain by mastering fire and cuisine. Cooking softens and breaks down food, dramatically trimming the energy costs of digestion. This metabolic downsizing of our guts redirects the saved calories straight to our most prized asset, the brain. It's the evolutionary deal that fortified our intellect and sculpted the course of humankind. In the cooking pot, we found not just nourishment, but the key to unlocking our mental potential. Part 3: Igniting Evolution: How Fire Fueled Our Minds and Bodies. Long before Homo sapiens walked the earth, the intellectual ascent of our ancestors had already set them apart from their primate brethren. Homo erectus, brandishing early tools and pursuing the hunt 1,000,000 years ago, was already on the path to a pivotal discovery, one that would be etched into the very fabric of human existence. This is where our tale takes a transformative turn. While the physicality of these pre-humans, sharper teeth, formidable jaws, began to diminish, their dietary shift towards meat marked a profound metamorphosis. The mystery deepens when we consider not just the sustenance of choice, but the revolutionary method of its consumption. Let's fan the flames of our narrative. The discovery of fire didn't just warm the hearths of our ancestors, it altered their biological and cultural trajectory. Nestled within South Africa's topography lies the Wonderwork Cave, a testament to continuous habitation that whispers of eras long gone. It was here, amidst its ancient chambers, that archaeologists unearthed the vestiges of fire use dating back a staggering 1,000,000 years, evidence that Homo erectus had already harnessed the transformative power of flame. This revelation of early culinary ventures aligns seamlessly with the evolutionary trend of increasing brain size, known as cephalization. Crucially, this aligns with the biological downsizing of our digestive system, a cost-cutting measure allowing energy to be funneled to our expanding grey matter. Cooked meat requires less mastication and enzymatic work than its raw counterpart, less effort for the jaw and more nourishment for the brain. The energy efficiency of fire-softened roots and tubers was unmatched, sparing our ancestors the exhaustive digestive labors faced by raw food processors like gorillas. In the hearth's glow, a smaller, more energy-efficient gastrointestinal system took shape, liberating those precious resources. This steadfast hearth companion, fire, became the crucible where our cognitive might simmered and grew, shaping us into the thinking, creating, and societal beings we are today. Part 4. The vital role of negative feedback in maintaining our body's balance. Tracing our evolutionary journey, we've recognized energy as the pivotal force in our ascent to humanity. But before delving deeper into our energetic essence, we must sidestep into the realm of regulatory mechanisms that maintain the delicate equilibrium of our bodies, negative feedback systems. Picture an efficiently run office, operating on the principle of punctuality. When an employee drifts from this expectation, the system recalibrates through managerial oversight. This process mirrors a fundamental biological principle. It's crucial to understand. Our very survival hinges on the body's capacity to autocorrect perilous imbalances. At the heart of this life-sustaining dance is the duo of a sensor and a switch. The sensor vigilantly monitors for any anomalies, while the switch springs into action, rectifying the system to its optimal state. Consider the workplace manager. She embodies the sensor discerning the tardy employee, and the switch invoking corrective action. Our bodies, intricate webs of living systems, echo this structure. Let's take hydration as an example. Our existence is inextricably linked to our water composition. Straying too far into dehydration or overhydration poses existential threats. Our biological self-monitoring is non-negotiable. Enter the kidney, our bodily hydration overseer. Through a chemical messenger, renin, it communicates impending hydration crises to the two switches in charge. The first nudges our brain with thirst, while the second dictates urine production, maintaining that precious 70% aquatic balance within us. Imagine forgoing water for a stretch of hours. Your kidney perceives this dry spell, signaling the first switch to awaken your thirst. Suddenly, water becomes the center of your world. Simultaneously, the kidney puts a damper on the second switch, concentrating your urine as it hoards every drop within you. Conversely, flood your system with excessive water, and a reversed scenario unfolds. The thirst dissipates and urine flows freely. This same intricate system of checks and balances governs not just our hydration, but our entire metabolic process. It meticulously marshals our energy intake, expenditure, and storage, each part locked in perfect, delicate harmony. Part 5. Metabolic adaptation. Our body's response to a calorie surplus. Just as we've uncovered how our bodies meticulously fine-tune water levels, we similarly maneuver through the intricate energy landscape. At the cellular level, our organs keep ticking thanks to a carefully regulated energy supply, a supply that, historically, was hard to come by, making energy storage vital for our ancestors' survival against famine's threat. Yet, a paradox surfaces. If energy could be stashed away without restraint, our expanding girth could hamper our evolutionary fitness. Herein lies the evolutionary compromise, a meticulous metabolic feedback system. Now, let's delve into an intriguing biological response. When we overindulge, our body's energy burning rate accelerates. Rewind to 1976, where researcher Ethan Sims initiates a compelling venture within Vermont's prison walls. Inmates volunteered for an overeating experiment designed to swell their body weight by 25% over a quarter year. As the prisoners' caloric intake soared from 2,200 to a staggering 4,000 calories daily, the initial weight gain followed predictably. However, the plot thickens as their weight gain hit an unexpected plateau. Sims responded by drastically increasing their caloric intake even further to 10,000 calories daily, yet some inmates still saw no additional weight gain. An enigma was unfolding. Sims dove deeper, examining the metabolic rates of the participants. The revelation was clear. Each subject's metabolism had revved up, churning through calories at an enhanced pace. Later studies, including a 2006 overview of multiple overfeeding experiments by the Mayo Clinic, corroborate that, on average, excess calorie consumption triggers a metabolic rate boost of approximately 10%. These findings hint at a safeguard our bodies have employed against excessive weight accumulation, drawing parallels to the kidney's regulation against overhydration. Yet, if this is indeed another negative feedback loop, it raises a pertinent question. Could it also guard against calorie scarcity and weight loss? If such a counterbalance exists, might it be the missing link in unraveling the oft-lamented failure of diets? Let's explore this further. Part 6. A tighter belt prompts a metabolic slowdown. At its core, metabolism can be distilled into an elegant mathematical truism. Energy consumed minus energy expended equals energy stored. To distill this further, the energy we derive from food powers our every action, from the physical to the cerebral. Excess intake nestles comfortably in our fat cells, waiting patiently for a rainy day. In the perennial pursuit of weight loss, the mantra is clear-cut: burn more calories than you digest. On paper, it's virtually infallible, echoed by diet plans the world over. Yet experience hums a different tune. Initial triumphs on the scales often plateau before escalating into weight regain. To demystify this conundrum, we turn our gaze to the science of starvation, carving our next key insight. Slashing calories leads to a sluggish metabolic pace. Step back to 1944, when Ansel Keys, a nutritional scientist with a visionary eye, orchestrated an experiment at Minnesota University probing the metabolic ramifications of starvation. After a 12-week phase simulating the caloric intake fit for manual laborers at 3,200 calories daily, Keys administered a dramatic cutback to a mere 1,500 calories, plunging the volunteers into a state of semi-starvation. 3 months into this regime, a shocking revelation unfurled. The metabolic rate didn't just dip, it nosedived, doubling Keys' projected drop of 25%. As he delved deeper, he uncovered their heart rates languishing, their breaths decelerating, their internal warmth diminishing. Their physiological functions were dwindling to conserve energy. Furthermore, this metabolic breaking had lasting repercussions. Once the dietary reins were loosened, their weight bounded upward at an alarming rate, surpassing their initial starting weights, exchanging hard-earned muscles for unwelcome fat stores. This bears a striking resemblance to our body's tactical response to dehydration, the initiation of negative feedback. Faced with a deficit, whether it be water or calories, the body diligently opts for conservation, throttling the metabolic engine to a crawl. Thus surfaces the axiomatic flaw in diets. Our intricate biological systems, lacking intent discernment, default to a survival protocol when faced with restricted caloric intake, stoking the fires of eventual weight regains. Part 7. The courier of our body's energy status. Leptin. Diets often falter under the weight of our biological programming. When we reduce our caloric intake, our body interprets it as a crisis, like a famine. In a well-meaning attempt at self-preservation, it dials down the metabolic rate, holding on to energy for an unforeseen future scarcity. And there's a twist. This lower metabolic setting persists even after normal eating resumes, predisposing us to weight regain. Yet, if our bodies fiercely defend against weight loss, do they also try to prevent us from tipping the scales in the other direction? Yes, and the secret lies within our fat cells, humming with biochemical chatter. Let's decode this message. Hormonal messengers are the arbiters of our body's weight. In 1994, a watershed discovery by Jeffrey Friedman introduced us to leptin, a hormone pivotal in this intricate signaling cascade. Fat cells aren't mere energy depots. They're endocrine organs that communicate with the brain, particularly the hypothalamus, the command center of weight regulation. Think of leptin as a barometer of energy reserves, steering the hypothalamus to toggle hunger and metabolic rate. Like a conscientious bookkeeper, when faced with excess, our fat cells dispatch leptin into the bloodstream. The vigilant hypothalamus reads the signal, recognizes the energy surplus, and acts swiftly. It appeases hunger and stokes the metabolic fires, thus curbing energy inflow and boosting stored energy burn-off, staunchly warding off undue weight gain. Flip the scenario. A strict diet whittles down the number of fat cells, which in turn dials back the leptin broadcast. The hypothalamus perceives a plunge in energy reserves, prompting a surge in hunger while simultaneously muzzling the metabolic rate. This adjustment not only curbs weight loss, but sets the stage for a rebound in weight once normal eating is resumed. One might surmise that this regulatory system should consistently shepherd us towards a healthy weight equilibrium. Yet, paradoxically, we find ourselves in the thrall of an obesity crisis, particularly pronounced in Western societies. Where does the system falter in the face of such widespread weight gain? In our final reflections, we'll delve into this conundrum, unraveling the complications in our body's communication network. Part 8: How the Western diet overshadows our body's weight regulation system. Our genetic ancestors once thrived on a rich tapestry of meats, tubers, and natural foliage, with an attuned balance of fats that fueled their hunter-gatherer lifestyle. Fast forward to the contemporary Western palate, and you'll find a stark contrast. The pillars of our diet have shifted drastically, punctuated by the startling discovery that a large chunk of the average American's caloric intake derives from processed foods, a trend mirrored across the Western world. This dietary transmutation threatens to disrupt the inherent metabolic feedback systems sculpted by eons of evolution. Our diet's detrimental transformation can be spelled out thusly. The modern Western diet has laid the foundations for an obesity epidemic. The 1970s brought with them a health scare, prompting a scramble for dietary culprits. Yet, the ensuing research wasn't entirely untainted by bias. It bore the fingerprints of industrial manipulations, with the sugar lobby at the helm. The result? Fat, especially the saturated variety in animal products, was vilified, while the ascendant sugar consumption slipped under the radar. A misguided war on fat was waged in the 1980s, a decision that echoes into today's obesity struggle. The consumption of certain processed oils climbed as the crusade against saturated fats grew. These oils, loaded with omega-6, are a double-edged sword. They prolong a product's shelf life, yet they also blunt leptin's signaling efficacy, impeding our ability to regulate weight effectively. In their quest to concoct irresistibly delicious yet low-fat offerings, food manufacturers swung towards another ingredient, sugar. Its usage skyrocketed by 20% since dietary guidelines shifted, spring-loading our blood sugar levels into a volatile dance. This excess sugar intake incites insulin overproduction, which leads to sugar crashes, continuous cravings, and a perilous cycle of overeating. While our physiology has innately evolved to combat obesity, this latent defense is incessantly overshadowed by the Western dietary landscape. The crux of the problem is clear. Our food environment has morphed at a pace with which our biology simply cannot keep up. Final summary. The story of life on Earth is one of remarkable transformations, shaped by the relentless pursuit of energy. As the progenitors of life harnessed more power, natural selection favored the evolution of intricate forms, ultimately birthing humanity with its hallmark trait, a prodigious brain. Our transformation from early hominids to Homo sapiens is a testament to our adaptive strategies in energy management, the mastery of fire, and the culinary arts. This leap in caloric accessibility was a game-changer, fueling our cerebral expansion while our digestive tract streamlined, optimizing our energy expenditure. Together with our burgeoning brain power, we developed an elegant metabolic feedback mechanism. Our internal regulatory system, dedicated to maintaining energy balance. In times of abundance, our metabolism revs up, countering weight gain. Conversely, during scarcity, it downscales, preserving every precious calorie. This delicate balance has been upended by the modern Western diet, whose heavily processed nature, bountiful in added sugars and altered fats, often undermines our body's intrinsic weight regulation capacity. Our health is ensnared in a clash between an ancient evolutionary design and a novel, calorie-rich food environment. In closing, our dietary past underpins every facet of our evolution, and it's through understanding this nuanced energy dance that we unlock the secrets to our weight, our well-being, and our place in the annals of life's grand narrative. Thank you for joining me today on this journey of learning and discovery as we explored the insights of another thought-provoking book in our growing library of knowledge. If you've enjoyed our time together, please take a moment to follow our podcast, give us a 5-star rating, and share 20-minute books with other knowledge seekers. Your support truly means a lot. Don't forget to join me again in the next episode, where we will delve into another enriching book. Until then, happy reading and happy listening.